The brigade, they'll have a small group of officers, maybe a dozen or so, that will already be assigned to the brigade, and they become very familiar with the supply chain. They work with an established brigade in terms of getting certain sorts of administrative and logistics support, and it's there somewhere. And so another value of sort of looking at the order of battle is looking at potential brigades that could be one of the first to be able to host this sort of capability. Now, if they do a full-range flight test, integrated flight test against a target at sea, it does not mean that that capability is going to be operational right away, because it still takes a year to 1, 2, or 3 years to be able to become confident enough to be able to call that brigade operational. So I'll throw that out there. Now, ballistic missiles by themselves don't really do all that much. Yes, they destroy things. They destroy runways. But it fits in with an overall concept of trying to gain air superiority. The most likely scenarios for having a conflict in the region in the future tend to be, coming right out of China's defense white paper, tend to be disputes over sovereignty issues, for example, with Taiwan, or territorial issues, dispute issues, for example, with Japan, or the two disputes with India. And in these sort of scenarios, it does not mean, of course, that China has intention today of using force. But certainly, as time goes on, their capability, should they decide to become more assertive in some of their claims, having the capability behind there to be able to be confident of having air superiority certainly allows them to be able to affect their interests with a lot more oomph behind it. But it's not enough, though, because you need to have an Air Force that is able to follow up. And the PLA Air Force, of course, is modernizing. There's no question about that. In the past, they relied heavily upon imports from the former Soviet Union or Russia, which is a reflection of some of the shortcomings of their aviation industry. But they're overcoming these shortcomings in a fairly rapid manner. And beyond the Air Force, you're also seeing emphasis on electronic warfare. Back in the good old days, electronic warfare, at least in the Air Force, was a major area of investment. With the advent of stealth, of course, it had gone away a bit because they serve similar purposes. The idea is to be able to push back the scope of a radar in order to be able to decrease reaction time of a defender. Stealth gives you that by reducing your radar cross-section. Ballistic missiles also give you that because they're also very, very small in terms of radar cross-section and moving at very high speeds. But electronic warfare is another way to augment, whether it's ballistic missiles or the aircraft, to be able to push back that air defense surveillance network. And this is an area of significant Chinese research and development interest. And not just going after air defense radars, but going against, for example, satellite communications. Electronic warfare is a high priority. There's a special organization set within the General Staff Department called the 4th Department, Electronic Warfare. They have operational units, at least one regiment, possibly two, one possibly deployed on Hainan Island, for example, that maybe just sort of a testing sort of organization, but they have a significant interest in space. And if I were a jammer or an electronic warfare officer, having something in Hainan for going after satellite communications or GPS, for example, could be very interesting. And the last part of this, of course, but not least, is the sensor architecture. Because generally, especially going after moving targets at sea, you need to be able to keep a persistent track on your target. Now, the degree to which you have that requirement depends to a certain extent upon what you have on the ballistic missile itself. Because if you have the ability to sense target out there on that vehicle itself, that could decrease your requirement. You may be able to make do with something just general strategic cueing. But the sensor network, of course, is a significant area of investment and priority. There are at least 4 parts of it to be able to give them that persistent surveillance capability out to a notional range of 3,000 kilometers. Where I differ from a lot of assessments, most assessments look at the combination of space, for example, electro-optical satellites or synthetic aperture radar satellites, in combination with a skywave over-the-horizon radar, or OTH backscatter radar. But what I see is a significant investment and interest in a program that actually goes back to World War II, which is the Hindenburg, for example, which is an aerostat that you can deploy up and with a sensor on it. But ever since at least, for example, 2005, there were a lot of studies that were done within the U.S. Air Force and DARPA within the Pentagon, looking at something called near space. Near space is if you look at where aircraft fly. Your normal fighter could be at 2,000 feet or 20,000 feet or 30,000 feet. SR-71s, for example, flew at about 70,000 feet. 70,000 feet in terms of kilometers, you're looking at about 20 kilometers in altitude. That area between, and the dividing line between the atmosphere and space, it's called the common line, KALMAN, is about that 100-kilometer point. And it's not a fixed point, but the things change the higher that you go in terms of chemical composition of the atmosphere and a whole range of other things. But that realm or that domain between 20 kilometers and 100 kilometers, to this day, today or in the past, it's been something to get through. Because, for example, if you're a ballistic missile, you want to get through that. That's where your burn comes in. Or that's where, if you're an Apollo spacecraft or a Chinese equivalent, your communications go out. But if you can actually operate in that environment for extended periods of time, it gives you an advantage, a strategic advantage, because it gives you that altitude. It gives you that sort of a look-down capability. And it's technologically challenging because it requires a different type of engine. So with this in mind, what you have is the establishment of two research institutes within the space and missile industry. One that traditionally is focused on ballistic missiles, the first academy underneath the China Academy of Launch Technology, that tends to focus on strike vehicles. And then another one, which is in Hunan, that focuses mostly on surveillance. And the 2nd Artillery, together with Hunan, has been looking at near space platforms as a key means of surveillance, persistent surveillance, that gives you a similar type of look as a satellite, but is able to fly higher. But you don't have to. But it's persistent; it stays in the area. So this is a very interesting development. So to wrap things up, though, looking at some other developments about what China's doing and the reactions that it's causing. Japan, for example. Japan traditionally has had somewhat of a pacifist approach. They've maintained a defensive orientation. They have plans to be able to modernize the Air Force and legitimate requirements to modernize the Air Force, looking at, for example, in the future, looking at a next generation fighter. And there are certain requirements for that, for example, to be stealthy, low observable, because it's significant requirements for air-to-air capability. But Taiwan, in many ways, is sort of the centerpiece of this, because it is arguably the focal point, the nexus of PLA planning. It is an easy-to-use scenario, and in many ways, if not an excuse, because it allows you to modernize without causing excessive alarm by others in the region. And Taiwan itself is reacting in a way that I think is underappreciated. There's been, for example, a lot of talk they need to do more hardening and things, which of course they do. But Taiwan actually, looking at what they're doing already for hardening, it is impressive. Then there's a lot there that doesn't seem to meet the eye. Some of the research studies that have been done on how to, for example, do rapid moment repair are nothing short of impressive. Looking at innovative ways, so not just looking at the U.S. as an example, but for example, looking at the way the Israelis do rapid moment repair. Looking at new types of concrete, or looking at new types of cement, rapid healing cement. They already have, in terms of kits, at least 300 rapid moment repair kits, with a significant number more in the planning stage. But also Taiwan, one of the problems with what the PRC is doing is that Taiwan is also looking at their own answer to the PRC ground-launched cruise missile with the Xiongfeng 2E. And their movement in this direction is understandable because of the difficulties now on maintaining a capability, a limited capability, that what they've had for many years, that's been robbed of that. So to be able to maintain that capability is significant. There's also been a lot of discussion that maybe they don't need, for example, a new generation aircraft. Maybe they don't need an Air Force. But I would argue that that certainly is not the case, because a lot of these arguments are based upon the assumption of one scenario, which is a full-scale PRC attack, amphibious invasion, when that is actually the least likely scenario. The most likely scenario for PRC use of force against Taiwan is limited coercive uses of force that have more of a political element than a military element. And having a first-rate Air Force